we move ahead to the next module of stationary waves. In this module, we are going to study the concept of MCQs which are based on closed and open pipe. To solve these MCQs, the first problem which is there in front of us is something like this. It says the air in a pipe closed at one end is in resonance with the vibrating tuning fork of frequency 170 Hz. So there is a pipe which is closed at one end. It is in resonance with the tuning fork of frequency 170 Hz. So can I say that frequency of the pipe that is closed at one end is actually 170 Hz? The velocity of the sound in air is given as 340 meters per second. The length of the vibrating air column is, so I need to find out the length. The options which are given is 100 centimeter, 50 centimeter, 300 centimeter and 25 centimeter. Now how do I solve the problem? Let me see what is given to me. I have the frequency that is 170 Hz, excellent. I also have the velocity that is 340 meters per second. Now I need to find out the length. How will I find out the length? Students, tell me, if there is a frequency of a pipe which is closed at one end, what is the formula? Yes students, the formula is N is equal to V divided by 4L. In this case, I know N, I know V, I know 4. So can I calculate L? Yes students, it's a very simple problem. L will be equal to V by 4N. Can I say V is actually 340 divided by 4 into 170. So can I say the answer will come out to be 0.5 meter, that is 50 centimeter, which is option B. Moving ahead to the next problem. Again, this problem is a very tricky one since it involves theory concept and it also involves the knowledge of the concept. If the fifth overtone of a closed pipe is in unison with the fifth overtone of an open pipe, so the fifth overtone of a closed pipe is equal to the frequency of the fifth overtone of an open pipe, then the ratio of the length of the closed pipe to open pipe will be. So they need to find out the ratio of the length of the closed pipe to the open pipe. I see the options. The options are 11 is to 12, 12 is to 11, 13 is to 11 or 11 is to 13. To solve this problem, let us write down the first given data. We know that fifth overtone of a closed pipe will be, can I say 11th harmonic? So fifth overtone of a closed pipe is 11th harmonic. Mathematically, fifth overtone is equal to 11N. Again, fifth overtone for an open pipe, as we all know, is the sixth harmonic. So I can say that open pipe fifth overtone will be 6N. Now I also know that in this case, at resonance, 11NC will be equal to 6N0. That means 11th frequency of the closed pipe will be equal to 6 times frequency of the open pipe. So can I say 11 times? Now frequency of the closed pipe, as we all know, is V upon 4 LC, length of the closed pipe, which is equal to 6 times V divided by 2 into L0, that is the length of the open pipe. Now we are relating only because they both are at resonance. Now from this, when we solve this, we get the ratio of LC by L0, which is actually 11 by 12. So from the question, we know that the option A is the correct option. Moving ahead to the next problem, it says there is an organ pipe. Now this organ pipe has a fundamental frequency of 100 Hz. Its second overtone is 500 Hz. What is the nature of the pipe? Whether the pipe is closed at one end, whether the pipe is open at both the ends, whether the pipe is closed at both the ends. Option D says sometimes open, sometimes closed. Now to solve this problem, we see the solution. Let us assume that this pipe is an open pipe. For an open pipe, second overtone will be 3 times N. Now I know that second overtone is 3 times N. So can I say 3 times the fundamental frequency? That means 3 into N, that is 3 into 100, which will come out to be 300 Hz. Now is the second overtone coming out to be 300 Hz? No. From the question we know that second overtone is actually 500 Hz. So it is definitely not an open pipe. Let us assume that this pipe is a closed pipe. For closed pipe, the second overtone is given as phi n. Now I know it is phi n, that means phi times the fundamental frequency, that is phi into 100, which will come out to be 500. And students, this is a closed pipe at one end because 500 Hertz is the second overtones value which is given in the question. So the option comes out to be option A, that is pipe is closed at the one end. Students, with the help of this module, we studied the problems which were based on the organ pipe closed at one end and open at both the ends. Thank you.